Hi everyone, I am Vijay Bhaskar. I am going to present my final year project titled AI-powered integrated medical diagnosis system. The project falls under the domain of machine learning, deep learning, web development, explainable AI, and generative AI. The primary objective of this project is to develop an intelligent healthcare platform that can predict diseases from symptoms, analyze medical images, assess heart disease risk, and provide healthcare assistance through an AI-powered chatbot. Okay, so let's move on to the next slide. Uh, Traditional healthcare systems often require multiple consultation, specialized diagnostic equipment, and significant time for disease identification. Many existing healthcare applications focuses only on a single disease and do not provide a complete diagnostic solution. Early disease detection remains difficult, especially in areas with limited healthcare accessibilities. To address these challenges, we process an integrated AI-based medical diagnosis platform capable of symptom-based disease prediction, medical image analysis, heart disease risk assessment, and intelligent chatbot assistance within a single system. This project presents an AI-powered integrated medical diagnosis system that combines machine learning, deep learning, explainable AI, and generative AI technologies. The system includes five major functionalities. The first is symptom-based disease prediction. The second is brain tumor detection. The third is pneumonia detection. The fourth is diabetic retinopathy detection. The fifth is heart disease prediction. Additionally, a retrieval augmented generation based medical chatbot is integrated to answer healthcare related questions. To improve transparency, saliency heat maps and AI generated medical explanations are generated for image predictions. For literature review, we analyzed recent research papers published in 2025 related to medical AI, large language model, medical image analysis, disease prediction, and healthcare recommendation systems. The reviewed papers highlighted the effectiveness of deep learning in medical image classification, machine learning in disease prediction, and RAG-based chatbots in healthcare systems. However, most existing systems focused on a single task. This motivated us to integrate multiple healthcare AI modules into a single unified platform. So, as I said, there are six modules in our project. So, I took three papers, two to three papers, research papers for each module. Yeah. During implementation, several challenges were encountered. The first challenge was integrating machine learning models, deep learning models, and the chatbot into one system. Another challenge involved handling different types of data, such as symptoms, image-based data, and text queries. Deployment was also difficult because large AI module consume significant memory and computational resources. Finally, ensuring smooth communication between front-end, back-end APIs and AI models, it requires careful system design, obviously. Okay, this architecture diagram represents the overall workflow of the system. The user interacts through the web interface by ensuring, entering symptoms, uploading medical images, asking chatbot queries, or filling heart disease forms. The request is sent to the appropriate AI module for disease prediction. Machine learning models process symptom data. For medical image analysis, CNN-based deep learning model analyze MRI scan, chest X-rays, and retinal images. For chatbot functionality, the user query is converted into embeddings and searched within Pinecone vector database. Relevant information is retrieved and passed to Grok LLM for response generation. The output then displayed through the web dashboard along with prediction results, heat maps, and AI generated explanations. Okay, our project was developed using Python as the primary programming language. Flask was used as the backend framework. TensorFlow and Keras were used for deep learning model development. Scikit-learn was used for machine learning models. For chatbot implementation, we used LangChain, Pinecone vector database, and Grok LLM. The frontend was built using HTML, CSS, and JavaScript. The system was deployed using Render Cloud Platform. The system consists of six major modules, as I said. The user interface module provides interaction between users and the system. The backend server module handles request routing and module integration using Flask. The data preprocessing module prepares some symptom data and medical images before prediction. The medical intelligence module contains disease prediction, chatbot, brain tumor detection, pneumonia detection, diabetic retinopathy detection, and heart disease prediction. The response formatting module organizes prediction results and recommendations. Finally, the deployment module hosts the complete application for real-time access. We used Rendar for our deployment. Okay, that's all from the PPT side. Let's move on to the coding part of our project. For the image analysis module, as I said, we have three modules: brain tumor, pneumonia, and diabetic retinopathy. We used the same code, but a different data for each module. So here, as we see, we will be getting the data, and we will be transforming the data by rescaling and all things. And after that, we will be creating the CNN layers, where we use the activation function as ReLU for the input layer, and obviously we will be having a pooling layer, flattening layer, and for the dense layer, I mean the output layer, we have used the activation function as ReLU, and and for the return we use the activation function as sigmoid for the output. In the hidden layer, we have used the optimizer Adam and the loss for binary cross entropy. After we starting the training, it have give us we actually made 25 epochs. So as the result, we had an accuracy of 98%, which is only applicable for brain tumor for now. So yeah, so this is how we made this brain tumor module. Same as we have also done it with pneumonia and diabetic retinopathy, but with a different data. Let's move on to next module, chatbot. Okay, now for the chatbot module, we had data in form of PDF. So I included a book for brain tumor, for diabetic retinopathy, for some common medical books, and for pneumonia also. We will be taking all these books as data, and we will be dividing it into chunks, and we will be converting into I mean the vector, convert the text into vector, and we will be storing it in the Pinecone vector database. Pinecone vector database is nothing but a place where you can store your Pinecone, I mean your vector storage. So this is our project's vector. So the converted vector will be stored here. As you can see, the record count is 94,000, where it combines all the medical PDFs that I have given. So obviously it's a large amount of data. We need to store it in a private or a public organization like Pinecone for better usability. So for that, we need to give a Pinecone API key, and also we haven't used the OpenAI API key. We have actually used the Grok API key. Since the API key we have mentioned it at, but the API key was given as a Grok API key, so no problem in that. As you can see, we creating the index name and doing separating the chunks and all things, and we are including the Llama 38B for this is the model in Hugging Face. Okay, so when the user is giving a prompt, the information is converted into chunks, and I mean the vector store, and the results will be displayed here as per the question given. Okay, let's move on to the heart disease prediction module. In the heart disease prediction module, I have a data set called heart disease, where you can see the attributes here, and I have deleted some of the attributes which are not required for our project. Attributes which is nothing but columns. Okay, so after this, I have actually converted the wordings into numerical form by adding label encoder, and I have correlation matrix, And yeah, after this, I have uh, developed the model. I developed the model with many algorithms. Like as you can see here, I used uh, here I used random forest classifier, and here I used decision tree classifier, and here I used logistic regression k-neighbors classifier. So among these, I got a better output in random forest. I mean, sorry, logistic regression. So I took this model and performed the final predictions. So that's all about this model. Let's move on to next module. This module is that the symptom-based disease prediction, where I have data set as training. So as you can see the data set, and I have performed a train test split and training top models like what we have done in disease prediction. So here I got 100% accuracy in every module. So I have also checked with the single prediction. It works perfectly. And I saved the model as SVC, I mean the pickle file, and whereas we can use this models at the end of the program. Okay, so okay, let's move on to the next module. As you know, we have 6 modules. I saved each module's model in pickle file and Keras for future works. So after that, we have a modules. Okay, now we shall open the front end of the of our project. Okay, this is the server. Our project has been running in the back end. Okay, this is the main dashboard of our system. From here, users can access all the healthcare modules, including disease prediction, medical chatbot, brain tumor detection, pneumonia detection, diabetic retinopathy detection, and heart disease prediction. Okay, so disease prediction. Here users enter symptoms separated by commas. The symptom vector is passed into our trained support vector classifier model. The model predicts the disease and returns description, precaution, medication, diet recommendation, and that's all the suggestions. As you can see, yeah. So let's move on to the next module, medical chatbot. So let me give the input as this. Like this is how a patient and AI will be communicating. Okay, yeah. So we need a high need internet has I mean high speed internet for to accessing this. I'm out of internet now, so that's why it's not working for me. Maybe you can get internet, then you will be getting the answers from the chatbot. Yeah, let's just move on to the next module, brain tumor. We will be giving a input as in image, the MRI scan of our brain. So yeah, let's give a cancer image. Let's analyze. Yeah, as you can see, it uses saliency and marks down where are the abnormalities from the images with compared to a non-affected brain. I mean, brain tumor, not affected brain. So yeah, so here it clearly says that the brain tumor detected and the confidence score was 99.9%. And also using the Grok LLM, it it given us the visual diagnosis like what happened in the brain and what are the root causes, what are the symptoms, what are the severity, what are the treatment options, medications, consultancy, and everything. So this is actually similar to the other modules called pneumonia and diabetic retinopathy. So let's move on to the next module, heart disease. So here it will be a form like the users need to fill this, and after clicking the predict risk, it will be giving us the final output. Let's just try. Here I have given us sample input. So let's just try. Yeah, once I click the predict risk, it shows that the input doesn't seems like affecting heart disease affecting input. So yeah, that's the output. And these are the references I have used for my project. These are very good references, I would say. So yeah, In conclusion, we successfully developed an AI-powered integrated medical diagnosis system that combines disease prediction, medical image analysis, heart disease assessment, and intelligent chatbot assistance within a unified platform. The system improves healthcare accessibility, supports early disease detection, and enhances transparency through explainable AI techniques. So yeah, thanks. Thanks for your time. Thank you.